starting. All attendees are in listen-only mode.
Hello everyone, sorry for the delay, but welcome to today's webinar entitled Getting Started with Solid Edge. This webinar is specifically designed for those of you interested in competing in the Razor PowerWing Design Challenge and are not familiar with Solid Edge. My name is John Gaioni and I'm Senior Marketing Manager with Siemens, and I'm joined today by Doug Stainbrook. Doug is a veteran Solid Edge field support engineer. He will be demonstrating just how intuitive and easy it is to model in Solid Edge. Before we get started with the demonstration, I want to briefly review the GrabCAD Challenge. Siemens PLM software, along with our partner KeyShot and Solid Edge customer Razor USA, are proud to bring you a challenge designed to create and design the next generation Razor PowerWing scooter. Think cool and get radical in your design. There are certain engineering specifications that need to be met, but from the design side, the sky is the limit. There will be over $14,000 in cash and prizes awarded to the top 10 entries. Be sure to be a part of that. A couple rules and requirements. You can find the complete list of rules and regulations on the GrabCAD Challenge page. In a nutshell, though, you must provide your design file in a Step-or-Digest form, and the final design needs to be modeled in Solid Edge and rendered in KeyShot. The deadline for entries is February 7th, so there's plenty of time left to design and enter the contest. So if you're new to Solid Edge, first step you need to do is download the free trial versions of both Solid Edge and KeyShot. Information on how to download both of these are on the GrabCAD Challenge page. The Solid Edge free trial version is a complete, full version of the software, includes great tutorials to help you get started and to design better along the way. However, we're going to actually give you a great demonstration today. So now I'm going to turn it over to Doug Stainbrook to show you just how easy it is to get started in Solid Edge. Doug, take it away.
Okay. Thank you, John. Okay, so everyone should be able to see the scooter on the screen now. This is going to be what we're going to be using for our demonstration today. Before I get started, though, I want to talk a little bit about what you do if you're new to Solid Edge. So let me close this window, just show you quickly here. When you first start Solid Edge, you're going to be shown this screen, and from this screen you can go into Solid Edge Test Drive, where you're going to be modeling some parts in a small assembly. There's also the ability to have your own learning portal to learn at your own pace, and I'm just going to click this link just to show you what that looks like. And so what this is going to do is take you to a learning portal, and so I'm going to just go straight to what you want to do. And what you're going to see here is there is a whole lot of different tutorials that you can walk through step by step, modeling from very basic parts to more advanced parts. And this is a great place to start if you're new to Solid Edge, if you've never used it before. So let's go ahead and go back into the scooter here, and what we're going to be doing is modeling a I seem to have lost my rotation. Just one second here. Okay, I'm not sure what happened there, but that's okay. So what we're going to do is we're going to be modeling the rear fender and adding some components and assembly. So first of all, I'm just going to go to a right side view, and we're going to zoom in on the rear wheel here. This is where we're going to be modeling the rear fender. And we're going to be building this in the context of the assembly. So this is what we call a top-down design, where you're modeling in the context so that you can make sure that it fits properly. And so the first thing I want to do is just go into some sketching features. You can see here all the different features that we have inside of Solid Edge. And I'm going to create, first of all, a sketch by just including, actually let me, getting ahead of myself. I've got to create in place first. I want to create a new part. And so I'm going to be creating a part, again, in the context of the assembly, and where I want to locate it is on the center of that wheel. And so when I do that, this is going to be what we call the rear fender. So what this is going to do is actually create a file on disk. And if we look over in the Pathfinder, you can see here's all the components that make up the Razor scooter thus far. And at the very bottom, it's going to add our rear fender, the part that we're going to be modeling. And so here you can see that we're in the context of the part, but you can still see the assembly in the background. And here I'm going to borrow some of that geometry from the background parts to actually create the new part. So I'm going to offset the outside of the tire here. We're just going to offset that just a small amount. And so that begins a sketch. If I hide the background parts, you can see that I have a circle. Next thing I want to do is add a line. Solid Edge has a lot of very nice, intuitive ways to create geometry, to create sketches. For instance, you notice I'm getting feedback up there in the quick bar. It's telling me how long the line is. I can specify that. I can say I want it to be 15 millimeters long, and I want to go minus 90. So that's one way that you can create geometry. You can also create geometry just by clicking. You can see that I'm getting an indicator telling me when my line is horizontal, another line when my line is vertical. And so then you can see that's how we build up the sketch. So you can see that it added that dimension when I placed it the first time. If I want to add another dimension, this is what we call the Radial Menu. You can put all your favorite commands on here. So when you right click, it'll bring up your favorite commands. I'm going to use a Smart Dimension. It gives me the length of that line, and right at this point I can then change the length of that line to 24. If I pick a circle, I get a diameter dimension. Another way to control it is if I click the line after I've created it, you get that same feedback. I could come back and make that 24. So this circle is going to represent the inside of the fender, and now I want to offset that to create the outside of the fender. 18 millimeters is what I'm going to use for my offset. And so there I have two circles. We're going to continue modeling here. I'm going to create what we call a tangent arc. So you can see it's coming off at a tangent. I can specify a radius if I want. And then I just want to connect it, and you'll see I get a little glyph telling me when I'm connected to that end. I'm going to come up here. This is where the end of the fender is going to be, and I'm just going to do two more tangent arcs. So this is going to represent our sketch. Now, in most CAD systems, you need to trim away the area that you don't want to use, and we could do that. We can come into the trim command, and if I just drag across those sketches, they'll get trimmed. But actually in Solid Edge it isn't necessary, because we use the regions inside of those enclosed areas. And so if I want to use all of those regions, I just simply select everything. I'm going to rotate the model here. Turn on the background part so I can see it. And now if I begin to drag, you see if I go this way, I'm creating a solid in that direction or a solid in this direction, or I can go in both directions by clicking the Shift key, because my sketch is right in the middle. Now, I'm going to use the background parts to tell me how wide I need to make that fender. So right there it's telling me that it's 39 millimeters wide, that cutout in the board. I want it to be smaller than that, so I'm going to just type in 38. And that's going to create our first solid. Now, you may want to change the color. That's really easy to do as well. I could come in here and just change this. Let's make it gold. That's going to match the rest of the parts that we're creating. The other thing I want you to notice is that the sketch dimensions that we used to create that solid have now migrated onto the solid. And so now I can directly edit those sketch dimensions that are on the solid now as PMI dimensions and modify the solid directly. It's very powerful in Solid Edge using what we call synchronous technology. Now it's not very Fender-like. It's very blocky. And so what I want to do is come in here and add some rounds. So let's round the top two edges here. We want to make this pretty large. We're going to make it 15 millimeters. Maybe I'll add a round to this backside as well. Now again, still not very Fender-like. It really needs to be hollowed out. Okay, I don't know what the command is in Solid Edge. I'm new to Solid Edge. I don't know if it's called shell, hollow, not really sure. So what we have in Solid Edge is something called Command Finder. So if I come down to Command Finder, I'm just going to type in hollow just to see what it finds. And it comes up and it says, well, there's a command inside of Solid Edge called thin wall. So how do I find it? I don't know where it is. If I take my cursor and just touch that command, you can see that it actually goes right to that tab and actually flashes where that command lives, so you can easily find it. Now I could go click on it there, or I can actually click on it straight from the command finder to start the command. Okay, so it's telling me I'm having a 2mm wall thickness, but I don't really know what the next step is. So down at the bottom it's prompting you on what you need to do next. And so what it says is I need to click on the faces to open. Well, I know I want these bottom faces to be the open faces, so I'll just click on those and you can see that it opens it up to the inside. Okay, so that's looking pretty good. Now I need some way to mount this. I'm going to go back to the assembly, turn the assembly back on here. And you can see that there's a screw that's going through this area. Well, again, this is the beauty of building in the context of the assembly. I know where that bolt is in the context of the assembly. So what I'm going to do is I'm going to reference that to place a hole. So I don't really know what size hole to make. So what I could do is under Inspect here, we have an option to Inquire Element. I want to find out what size that cylinder is. It's a 5mm cylinder. That tells me that's a 5mm bolt that's going through there. So I want to make a clearance for that, probably like 5.5mm. But in order to locate it, again, I need to include. I'm going to lock onto that face, and I'm just going to pick up the head of the bolt. What that does is just project that head of the bolt onto the side of my part, so that I can use that for location to actually go back and build a hole. The hole that I want to create, again, I said is going to be 5.5mm. And I'm just going to locate it on the center of that sketch. And so there you can see that we have our hole going through the fender. All right, so far so good. Let's go back to our background parts here. And if I look underneath here, there's a spring because this is actually used as a brake. So there needs to be a cutout in that area for the end of the spring to come through. So what I want to do is create a cutout on that face. So I'm going to use a rectangle by center. I'm going to lock onto a face here. This is the face that I want to lock onto. I'm going to pick up the midpoint. Notice I'm getting feedback as I drag my cursor. It tells me when I'm on the midpoint. And I'm just going to sketch a rectangle. And then I'm going to use that region of the rectangle again to actually cut away and create a hole in my part. Now if we want to angle that face, Solid Edge has some very powerful functionality. You can see we have this steering wheel. I'm just going to place it on this edge, and that's going to allow me to actually rotate that face. Now notice that the face on the opposite side is rotating as well, and that's because it's a symmetric part. We recognize that it's symmetric, and we try to maintain that symmetry in the part automatically, so it's nothing you really even have to think about. Let's add some more rounding. We want to round this area. Let's go with a 5mm round. And let's just round these corners quickly. May even want to round this front edge. So some very powerful tools there. So that's looking pretty good. So let's go ahead and go back to the top level assembly now. So now we're out of the part. We're looking at the assembly of these parts. Move this down. And what I can see is that I have a little bit of a problem here. I can see that I'm interfering. So what can I do about that? Well, Solid Edge has a way to select faces from the assembly level. So under the Select tool here, I can say, well, I want to pick faces instead of parts from the assembly level. And I can pick that small face, pick that steering wheel, and I can actually drag it back to create the clearance and fix that interference problem. This is something unique to Solid Edge. It's very, very powerful, this synchronous technology. Now the spring actually needs to be a little bit longer because I've made that hole bigger. So I'm going to grab the end of the spring and I'm just going to drag it down. So you can make modifications really, really quick. Okay. All right, so that's looking pretty good. Let's go back to a right side view here. I want to make another modification here. Let's make the end of the fender a little more stylish. Notice that just by rotating that face out, I can make that look a little bit cooler. Or maybe I want the fender to wrap. I'm going to select the entire end of the fender and put that steering wheel on the center again. So I want to rotate about that center. And you can see that now I can wrap that fender further along, or actually I can back it up if I want to add some more flair to that. So far that's pretty cool. Now let's really make a radical change. I want that tire, that wheel, to be wider. I want to have a big wide tire in the back. So what I need to do to widen the tire is, first I want to widen the wheel. I also want to widen the tire. When I do all that, I'm going to need to widen the fender. I also need to include the hub, the face of the hub. And then, of course, if I widen all of that, the other thing that I need is the cutout. So I want the face of the cutout as well. I got one face I didn't want there. Let's come back and get that hub face. Now, if you're not able to get the face that you want, you can hover there for just a second, and it will bring up what we call Quick Pick. And then you can go and pick exactly the face that you want from the location of the cursor. So there we have all the faces that we want to modify. And I'm going to modify these all at once using synchronous technology. So again, this is in the context of the assembly, and I'm modifying 3 different parts all at the same time by just dragging. And I can key in a value, make it 6 millimeters. So that's 12 millimeters wider in total because it's symmetric, so it's moving both sides at the same time. Very, very cool stuff. Now while we're here, let's do one more thing. Let's go into the wheel. And what I see inside this wheel is that I have a cutout. Now I don't really know which feature that cutout is. And to be honest, I really don't care, because with Solid Edge I can just simply select that cutout with a fence and create a circular pattern. And maybe for this pattern you can see that it's 3. I want to up that to maybe 5. So now that I have my pattern, again using synchronous technology, I can really make some radical change to this just by clicking and dragging. So it's really cool for doing conceptual design as well as production work here. So that was a native Solid Edge part. What happens if we have imported parts? Let's come up here to the top. Here I have a grip. Let's edit this grip. What you're going to see is I actually imported this from some foreign CAD system. So what you can see is that has no features. It's just a part copy. But with Solid Edge we don't care. We can modify this as though it is a native Solid Edge part. If I pick a face, I can change that diameter, make it 50, as though it was built in Solid Edge. Pick this round, for instance. It'll find that, it'll find that face, and we're going to make that 2 millimeter round. Want to add some rounding. Let's add a 2 millimeter round onto these edges. Very quick and easy. And now let's add one more feature. I want to add a grip. I want to add actually fins or cutouts in this guy. So I'm just going to use that rectangular sketch. We just need to find the midpoint. Again, getting feedback, you can see it's going to tell me when I get to the midpoint of that edge. If I go in the right direction. There we go, midpoint. And so I'm just going to sketch this out. I'm going to use this to create a cut in my part. So I'm going to cut in both directions here. Just make a small slit. Let's add some rounds. And just like I did with the wheel, I'm going to take that round and that cutout, and I'm going to create a pattern. In this case, I want about, let's go with 16. So very, very quickly and easily, I'm able to modify that imported part as though it was native solid edge and add whatever features I want to add to it. Now let's go back to the top level assembly again, and let's say that there was a design change. Somebody wants that grip to be, say, 5 millimeters longer. Well, again, from the assembly level, I can go into that face priority mode. I'm going to fence select, so I'm going to get the end of the gold bar as well as the end of the grip that's imported. Move this off of here so you can see what I'm doing. And I'm going to start dragging this, and I'm going to actually modify both parts at the same time, the imported part as well as that gold part, and make it 5 millimeters longer. Let's say I didn't like that change that I made. Right from the assembly, I can even get to that diameter. Let's go back to 45, the way we had it. So some very, very powerful functionality for editing even imported data. Now what we want to do is I just want to show you how you assemble parts very quickly and easily. So from our parts library, you go to wherever your parts live, and in this case, I'm going to add the front wheel assembly. I'm going to bring in my front wheel assembly, and where do I want to place it? Well, I want to line up these two cylinders, and I also need to center it. Well, I don't really have a plane. I don't know where to actually center it, but that's okay. We have a center plane command inside of Solid Edge, which will allow you to pick two faces. So let's pick the outside face of our sheet metal part. Okay, let me move this over. So find the center between those two faces and align it with the center of the wheel. Find the center of the wheel as well. And it will center those together. So now that wheel is directly in between those two faces. Now obviously it's not going to stay there without an axle, so let's quickly add our axle. We can even, if we place the same parts over and over, we can actually teach those parts how to be assembled, so we don't have to do a lot of picking. So there you can see I quickly added that guy, and let's add the nut to the other side, the special nut. Doing the same thing. You can see it has a diameter, it's looking for a diameter to align to, and then it's looking for a face to mate to. Okay. And then finally, let's do one more thing. That's a sheet metal bracket, that front fork. Well, there needs to be a bracket here for this brake. So when you pull the brake handle, it tips the fender into the tire to help you stop. But right now there's no flange there. We need to add a flange. So notice I'm in the assembly. I'm just picking up the edge of our sheet metal part. And if I pick this small arrow and start dragging, I can actually start dragging a flange. Now right now it's interfering because I actually want that flange to have the bend to the outside of where I selected. I want it to come right up to the bottom of that nut, and then I'm going to drag another flange in this direction. And this time I want the bend to the inside because I told it where that nut was. And so there you can see that we were able to add those flanges very quickly. One last thing then is I want to add a hole. There's no hole in that flange because I just created it. And right from the assembly I can go into the hole command, and I want to pick this top face is where I'm going to be placing the hole. Zoom out here a little bit. A whole lot. All right. And zoom back in. Now, to locate that hole, I'm going to actually use what we call peer parts. So I'm going to use the background parts to determine where that hole should be. So as I touch this, you can see it's giving me a circle, and I just go locate that center point. That's where the hole is going to be. And we want to cut that through all of the parts below it. It highlights all those parts. Now, obviously, I don't want that hole through everything. The only part I want it in is the sheet metal part. And so if we edit that part in place, then we can see there's our hole. Now that flange is pretty wide, so again, I can come in here and do some fancy stuff like rotating these faces. Again, stay symmetric just like it did in that cutout. Might want to add a couple of breaks to the corners here so somebody doesn't get hurt. And we'll just pull this face back. So a lot of stuff you can do with synchronous by just clicking and dragging. Then, of course, with sheet metal, it's very important for manufacturing to be able to flatten it. Of course, we can do that inside of Solid Edge. Just go into our flatten, and there it gives you the blank size for what it would take to actually create that part. And so hopefully you've seen throughout this demonstration how easy it is to model with Solid Edge, how easy it is to modify parts with Solid Edge, whether they're, you created them in Solid Edge or even imported them from somewhere else. So with that, I'm going to flip it back over to John. Okay, John, you may be on mute.
Okay. Yep. Thank you, Doug. Great demonstration. And I wanted to share this this picture right here. We mentioned KeyShot. KeyShot's a partner of Solid Edge and a partner in our contest. This is an amazing rendering of the model that Doug was working on. KeyShot's just a fantastic rendering application that integrates completely with Solid Edge. And you just take your Solid Edge data and you can create stunning visuals in just minutes. Really nice stuff, really cool, really fun to do. So at this point, we're going to open up the floor for any questions. Please type in your questions and we'll see if we can get your answers for you. So go ahead and type them in. Okay, no specific questions. I do see a comment. One of the audience members, I'm using version 19 in college and now trying with the latest release, which is ST6, and I can sense it was a huge leap. Definitely, and that's a great part of the trial is that you get to try and check out the latest software version. So glad you're able to check that out. Anybody else have any questions? Please send them in there. Somebody's asking if the session's being recorded. Yes, and we will post the link of the recording in about an hour or so. And the last question, can the current scooter CAD model be provided in GrabCAD in the GrabCAD page for participants so that it could be used for improvisation? Now the whole idea is for you to go ahead and come up with that great new design. So sorry there, but as Doug just proved, it's pretty quick and simple to do in Solid Edge, and we're really looking forward to seeing your designs. Okay. All right, well, we're going to wrap it up here. I'm going to post my information. A couple next steps, actually. So your next steps here would be, if you don't have Solid Edge downloaded yet, you can do that by going to siemens.com/plm/try-solid-edge, as shown here on the screen. Download your full version and start designing there. And you got about 23 days before the contest ends, so Looking forward to seeing all these entries. Thank you again for joining us today. And here's my information. Should you have any questions, please feel free to email me. I can be reached at john.gaioni, which is G-A-I-O-N-I, at Siemens.com. Thanks again, everyone, and we look forward to seeing your designs in the GrabCAD Challenge. Thank you.